Hello, this is Danielle Tran, Senior Industrial Engineering major at Cal Poly San Luis Obispo, and this is my Senior Project Part 1 video covering the design of a database for the local startup Boltabout. This presentation will cover an introduction to my senior project, which will include a problem statement and objective, the current state, a background, and the design objectives of this database. Boltabout is a startup based out of San Luis Obispo that functions primarily as an electric bike rental company. They have seen great success over the past 2 years and are looking to expand. As the company expands, their CEO desires more accurate metrics on their bikes. This is needed to track the status of the overall fleet in order to ensure swift repair and adequate supply. Accurate data is also required in order to make well-informed decisions for future forecasts and decisions. In addition, Boltabout will also need to be able to monitor customer history to maximize customer retention. Boltabout currently has no central database and therefore only has access to very limited data in making their decisions. They would like me to build them a database that will accurately track all bikes, maintenance history, and customer history, and output executive reports to monitor costs, trends, and current fleet status. Boltabout is strictly using Microsoft Excel to record all data on their bikes. By having a system that solely shows the current state of things, they do not allow for a concurrent recording of a bike or customer's history. Since Boltabout is using shared Excel documents which are updated in real time on the internet, one person's mistake can wipe out everything. Using the current state also does not allow for company insights. There are no charts or analytical data to draw from or forecast from. How do databases work? Data and applications are stored on a hard drive or a series of hard drives or other media such as a cloud. All of this storage is managed by the operating system. The operating system, which is Windows in this diagram, handles all of the low-level tasks associated with running applications as well as managing storage. SQL Server runs on top of Windows. SQL Server is actually dozens of modules, which are separate pieces of software. Each module is called when needed. This diagram has been simplified to show only the query processor and security. The query processor translates SQL into a form of code the other server modules can use. All communications with the server go through the security layer. The security layer is a blending of operation system functions and functions specific to SQL Server. SQL is the communications protocol between the SQL Server and the outside world. Most communications with SQL Server are in standard query language. On the right of this diagram, there's a box called the SQL Server Management Studio. SQL Server Management Studio gives us a single location to manage our SQL servers and develop and test our databases in SQL code. Before one can manage servers or run SQL code, they must set up a connection to each server they want to work with. The servers can be anywhere. The only requirement are a network connection and security clearance. For my project, I decided to utilize a cloud-based service called Database as a Service. Database as a Service is a software that enables users to provision, manage, consume, configure, and operate database software. It is operable by using computing primitives to interact with software without needing to know its exact implementations. So why use Database as a Service? Well, Database as a Service is adaptable. It is perfect for applications that require quick changes in scale, such as for startups. They are economical, and they only require about $5 per month to maintain a subscription. They are agile. They work well with dynamic applications to increase agility, organization, and accessible, usable data. Specifically, I'll be using Microsoft Azure. Microsoft Azure is the facilitator that connects certified databases such as Oracle and MySQL to the developer and end user. This simplifies the provision and management of databases to offer its users self-service, managed databases for other database platforms. Microsoft Azure is where the database is created. Databases consist of a front end and a back end. The back end refers to everything that the user cannot see in the browser. It consists of the framework of how the data is stored, managed, and updated. The front end is the client-side interaction. It involves everything that the user sees and how they interact with the data. For the back end, I will first need to sign Boltabout up for the cloud service Microsoft Azure. Through Azure, I will be able to import Boltabout's current data regarding bikes, customers, history, etc. into a MySQL database where it will exist in the cloud. The current data usage dashboard can be used through Azure. For the front end, I will need to find a service that the clients will use to interact with, to access, edit, and gain insights from the data. The exact service has yet to be determined. The current options include Microsoft Access and Tableau. Access is an affordable but basic and less professional service. Tableau is more expensive, but much more detailed and insightful. This concludes a brief overview of my project. Thank you for your time, and I look forward to hearing back from you soon.